Hello class, welcome to lesson 16/17, rates to ratios. If you notice, we are combining 16 and 17 because they're relatively short and very similar. Now I'm going to zoom in to the first half of the page. Probably be a good time to pause it. And now we're going to zoom in to the second half of the page. If you notice, before we get started, down here you see a section that's titled Your Work. This section right here. What that means is tomorrow you have to come to class having this question answered. You can write it in your notes with all the work attached. We're going to go over that first thing in the morning. However, let's jump right in to the lesson itself. So we're starting out, and our hope is to be able to answer the question, how can I use a rate to find associated ratios to that rate? Now, if you're not familiar with rates, you might just think, oh, that's a word that sounds a lot like ratios. They're similar, but not quite the same. Some common rates that you might have heard of are, for instance, miles per hour, MPH. Every car has that. You might also see rates such as BPM, which is beats per minute. Specifically, that's pertaining to heartbeats per minute, and it's used a lot during the medical field to see how quickly someone's heart is beating, to see whether or not their blood pressure is high or low or things like that. Another commonly used one that you've seen probably in a lot of our word problems in math is when you're typing on a computer or text or whatever. A common one is words per minute. So, as you can tell, most of our rates, at least the most commonly used one, have to do with how quickly you can do something in a given amount of time. They won't always be task to time related, but usually they are structured with some number on top, usually the number of how much of something you can achieve per the time it takes to do it, usually. So this line right here, this fraction line, where we know that as being referred to as per. So now that we know sort of what a rate is, we can take a look at how to turn, like our problem says, how to turn rates into ratios. So first step is to identify the ratio, and then it's really easy. You just scale it up or down. Multiply it by the same number going up, divide it by the same number going down. So our example here is talking about a young man named Devin. Devin likes to play basketball. So if Devin can make 20 shots in 4 minutes, how many can he make in 10 minutes? So if we're looking at our task here, it says identify the ratio. Okay. So let's go ahead and do that. We can identify our ratio as 20 shots in 4 minutes. So our ratio here is going to be 20 to 4. And now our task tells us that we just need to scale it up or scale it down. In order to scale it up, you know just as well as I that you multiply by some number over some number. It can be anything. We could say 3 over 3. So 20 times 3 is 60, and 4 times 3 is 12. So there we have it. That's a scaled up ratio. And now if we want to scale our ratio down, same thing. Just start with your original 20 over 4, and instead divide that by something that goes into both. So 2 can go into both. We know that because they're both even. 20 divided by 2 is 10. 4 divided by 2 is 2. So there's a scaled down version of our ratio. That is one technique we can use to scale our ratio up or down. Another technique we can use, we could do tape diagrams, we could do graph, we could do whatever. One more example I'll show you would be a table. So if we take our ratio and put it in a table, we've got shots he made to minutes it takes. Let's go. We've got 20 shots per 4 minutes. If we want, we can double both of them. 20 times 20 is 40. 20 times 2 is 40. 4 times 2 is 8. So you could double them. We could extend that table even further, and so on and so on and so on. That's the way you can scale it up using a table. What I've chosen to do here on these notes is use a double number line. I think it's easy to use and easy to understand. So what we've done here is we've taken Devin's ratio of 20 shots to 4 minutes and we put it on a number line. Our X value is shots, so that's our top line. Our Y value is minutes, so that's our bottom line. So we start with 20 to 4 and then we just continue to scale it up. So we go from 20 to 4, 30 to 6, 40 to 8, 50 to 10, 60 to 12. So the question here is, if we look back here, how many can he make in 10 minutes? So let's come to our double number line that we created. We're looking for minutes, so we start on our minutes line. We got 4 minutes, 6 minutes, 8 minutes, 10 minutes. All right, that's what we're looking for. So in 10 minutes, he can make 50 shots. And that's our answer, isn't it, down here? Devin can make 50 shots in 10 minutes. Booyah. Question answered. So let's see if I can get rid of some of this stuff. Move on down to the bottom. Okay. If you're not sure how I got from, I started with my ratio of 20 to 4, and you're not sure how I just really easily came out here, made 30 to 6, 40 to 8, 50 to 10, and 60 to 12, I'll give you a little hint. What I did is I took my X value and I divided it by my Y value to find my multiplicative constant. So 20 divided by 4 is 5, which means that my multiplicative constant here is 5. And if you need a little bit further explanation, that means I can pick absolutely any number I want down here, and all I have to do is multiply that number by 5, and it will give me the number that corresponds with it up here. So, if I wanted to, I could pick 7. 7 times 5 is 45. So its partner up here would be 45. I could pick 11. Put 11 down here. 11 times 5 is 55. So its partner up here would be 55. That's how I found all those numbers on that number line. So let's go ahead and get rid of this stuff and look down at the Your Work section. So, all right. Your work. Using that same ratio, I would like you to figure out how long will it take Devin to make 12 shots. Some options you can use. You can use a double number line just like I did. That's probably the easiest because it's already there for you. All you have to do is extend it. You can use just straight up multiplication. Use that multiplicative constant of 5 to figure out how long it will take him. I'm not going to give you a hint as to how to use that multiplicative constant. If you know, that's good. You can use a table if you want. You can even use a graph if you're feeling real excited. Lots of options. You could use a tape diagram. You could just do the straight math. You could draw a picture if you want. However, you can figure that out. Works for me. Come tomorrow, ready to show your answer. Have a good night.